thank you for coming, Rafael, Dr. Rafael Kim.
Yes.
That's the best way to call you. Yeah, we've got about 18 students to get started. So just a
Yeah.
quickly introduction, the current introduction that you sent me actually. So you're the founder of the Biodesign Academy. It'd be nice to hear a little bit about that project.
Yeah. Sure.
I had a look a couple of times. I mean, it looks really, really interesting. But
Mhm.
would I think be nice maybe as a follow-up is for students actually to go and have a look at what you're
Mhm.
doing there. And so you have a background in biotechnology. So we've had a lot of people on the side of humanity. So design, I like this. I don't know if you do this drawing where you have design in the center, science on one side, and humanities on the other side. So we had a lot of people on the humanities side so far about regenerative design
Mhm.
and such kind of stuff. So I think you were the first one kind of going on the science side, and that might be a
Mhm.
bit more of a challenge to me. But I'm definitely looking forward to hear what you have to say. I
Yeah.
think what you have to say is probably very anchor in the contemporary. So you have some laboratory research in protein chemistry, including work at La Roche
Mhm.
and a PhD in interaction design, you were saying at Queen's Mary.
Yeah.
Our connection is through the Royal College of Art, where you did study I think students will probably don't know, but a very famous course on interaction design or design for interactions, rather. And then your specialism has been in the intersection of biology, design. So I just mentioned the RCA, the
Mhm.
artificial intelligence. I think that's probably a new thing to you, right?
Mm.
AI. Okay,
Yeah.
focusing on how emerging biotechnologies reshape design practice, material culture. Oh, nice, good. And education.
Mm.
So maybe not so much on the science part. That's good.
Yeah.
You have taught and lectured internationally in biodesign, regenerative design. Again, that's a theme that we had a couple of weeks ago, and AI integrated design practice. Good. Your research and writing explore sustainable material development, AI-driven protein design, I guess part of that, and the shifting
Mm.
role of designers working with living system. So yes, so I'm very, very much looking forward to your presentation, really.
Great.
As I, as I
Yeah.
say, you may be repeating things that you guys have heard in your different kind of courses. Whether and you're not going to talk too much about AI this time,
Mhm.
but which is fine. Yeah, there's a couple of teachers, I think like Bolu, for example, we're kind of looking at the biological element or the chemical element of material in terms of reducing the carbon footprint of
Mhm.
material. I don't know. There might be some repetition, there'll be some difference, and I'm quite happy that either repetition or differences is something that we can learn something from. I think that's the goal of these different talks. So thank you
Yeah.
so much for coming again, and
Yeah.
it's up to you now.
Okay. Yeah. Thank you, Nicholas, for your kind introduction. And yeah, really happy to be here and giving a talk to you guys. So feel free to ask any questions at the end. Happy to engage in di dialogue and conversation about this topic. So what I can do, I can just quickly share my screen, and then I can give you some images to share. This one. Just taking a little bit of a while to kick off.
That's all right. And we have normally three students scheduled at the end of your presentation who has been tasked to ask you a question. But you
All
know,
right.
we'll see. But again, if more students want to ask a question, this is also very much welcome. But three of you say they will be asking a question.
Yeah, perfect. Perfect. Thank you so much. Okay, so good evening, guys. So what I will do, I'll give you a quick talk on designing with living systems. Now we are thinking about biological living systems using as a design material and how that may affect or help you with your research and your study. And I'm really very much looking forward to this. So a quick introduction, which Nicholas has kindly provided. I'm not going to go over this again. So I have a mixture of biology and design background with a PhD in interaction design. And I'm currently the founder of Biodesign Academy. Okay, so let's just jump straight into it, shall we? Let's talk about biodesign as a starting point for our discussion. So biodesign is a very loaded word. It originates many decades ago, but essentially one of the core aspects of this biodesign is this idea that you're integrating biological processes and living organisms in design. And it has different implications, of course, because things are living, breathing, reproducing, and decaying. I suppose one of the main images I conjure up when people mention the word biodesign is this idea of working with nature. One classic example of biodesign I can imagine is the root bridges that are found in Meghalaya, which is part of India. So this is a bridge with an exceptional past. So what happens here is that the bridge is not completely man-made. It's actually a collaboration between the human beings and the nature itself. So over decades, these kind of trade roots have been intertwining and interwoven into these structures that people have aided or guided slightly to cross these parts of the rivers. And over centuries, these roots have formed a special relationship with the human traffic to kind of weave itself into this kind of mechanical looking bridge, which has been uh, overcoming the test of time and is becoming very mechanically strong and agile and very sustainable to actually use. So there is a theme emerging of the human nature collaboration, and this is one of the fulcrums of biodesign today. There are probably hundreds of different types of biodesign projects that are out there, whether it's academic or commercial. Let me just run through some of the very classic popular biodesign examples that use sustainable materials for producing products and furniture and even architecture. So these are one of the top ones here. The left-hand side is done by a company called Modern Synthesis. It's a London-based company. It's a fairly new company that specializes in fabricating with not just synthetic textiles, but they actually grow vats and vats of fermented bacterial cellulose, which are the byproduct of bacteria and yeast collaboration. So you can provide these highly mechanical, tough, and resilient materials from bacterial cellulose. And their whole business model is based around creating sustainable fashion items, whether it be a jacket or a handbag and so forth. Bacterial cellulose, by the way, if you don't know, are the main components of kombucha. A byproduct, shall we say, of kombucha is a popular drink that's been fermented using microbes. Soundproofing panels by Mogu is another classic one, example of biodesign, this time using mycelium, which is a part of a fungal growth, to provide soundproofing materials. But this is, I would say, one of the many examples of how mycelium is being used. In fact, mycelium is probably the most common material, sustainable material that are used in design right now. And there have been other cases involving mycelium generated packaging materials, like this packaging on the third example here. Algae that are photosynthetic, using sunlight to generate energy. And that's another classic organism that's being used in biodesign. So the fourth image here on the top is one of the speculative projects that use algae to produce a fabric that breathes and interact with the human user to create a natural environment. The fifth example is what we call a living coffin. So this idea of collaborating nature is very strong here. So this example is where it's a business that's driven by the idea that we should produce and design products that are sustainable. So the whole coffin is made from mycelium, and when the body of the deceased is placed in the coffin, over a long time, this would actually interact with the mycelium fabrics of the coffin to become part of the earth. So it's a general idea that you can work with nature to create sustainable materials even after your death. Even after your death. There are a few more examples. I'm not going to go too much detail, but just to give you some flavor. If we look at the bottom, the first image from the bottom, it's a bioconcrete. So this is another famous example done by researchers called Henk Jonkers and the team at the TU Delft. And so this is the idea of living concrete, which might be a little bit closer to the architectural context. So bacteria has this habit of producing calcates through biochemical reactions. There's a very specific strain of bacteria that these people use. So the idea is to self-heal or modify architectural structures by injecting spores of bacteria within the concrete. So the general idea here is that once a crack appears that are incredibly small and fragile, the bacterial spores would actually wake up given this crack. So that would trigger a biochemical response, which would produce a calcate that would actually firm up this concrete structure. There are many other biodesign examples involving mycelium and bacterial cellulose. Some people are working with living roots, so going away from microorganisms, now going to plants. Yeah, the interwoven project is a good example where the living roots have been used to fabricate sustainable structures. In the middle, this is a project by Nova Innova, based in Netherlands. What they're doing is creating some sustainable lighting systems that are generated not through batteries, but by bacterial activities. I do apologize for the smallness of these images. I will go into more details project by project in the later slides. So, but just to give you a snapshot, this would be one of the handful of very famous examples in biodesign. And I've listed the reference of the names of the designs for you to check it out in more detail. So as a designer, there's always been kind of this divide, like Nicholas mentioned earlier, about science and design. There's been a great chasm between the two communities. But I suppose one of the ways of thinking about this is to think about living things as materials and designable collaborators. And one of the concepts to think about is this idea of synthetic kingdom. This was proposed by a designer called Daisy Ginsberg back in 2009. So this is the idea of not creating a living kingdom in a traditional sense. These are the synthetic kingdoms that are powered and driven by synthetic biology to engineer, modify, and fabricate with living systems. So this is one of the core tenets of how biodesigners could think about when it comes to living and using living materials. So there's a lot of noise in biodesign and sustainable materials engineering. I suppose one of the ways to think about living materials and sustainable materials is to think about living artifacts. One of the research done by Alvin Karana and his group in TU Delft in Netherlands is this idea of creating living and designing living artifacts, which allows the livingness as a material quality in designing everyday artifacts. So this is based on a famous paper by Alvin Karana's group in 2020, and I can link the paper article after the talk. So Living Cocoon, the Living Coffin by Loop Biotech, as I briefly mentioned earlier, is a classic example of a living artifact where the product is living material itself that can combine with the human body to create something that's sustainable, at least from a funeral and post-death context. So let's talk about the three fundamental pillars that are underlining the concept of living artifacts. There are three different pillars: living aesthetics, mutualistic care, and habitabilities. So these might sound very conceptual to you guys, but I'll give you some examples to illustrate what I mean by this. And this, I would say, is a nice way or a guide to think about how to design with living materials. There are a lot of theories and scientific data out there, and people might get a little bit overwhelmed sometimes. But if you think about it in terms of living artifacts and the three pillars, that might guide you in your exploration better. So when we talk about living aesthetics, this is all about acknowledging the different temporalities that are prevalent in biological process of change. So unlike conventional artificial materials like plastic, metal, and wood, if you work with living artifacts, there are temporalities, right? It's always changing, evolving, even mutating and hibernating and decaying. So once we acknowledge that this material is not static, it always changes, it grows, it dies, it replicates. It's a good starting point for us to think about designing with living systems. If we acknowledge it, we change our paradigms, we change the way we work and the workflows as well. One of the projects that I've been working on as part of my PhD is this thing called Mold Rush that really acknowledges the temporalities of living systems. And living aesthetics is a very prominent feature of this research. So Mold Rush is a slow biotic game. What I mean by biotic game is that it's a very strange biodigital gaming environment where you're interacting and playing, not with another person, not with another computer system, but playing with a microorganism. This project is a real project that uses the slow growth of microorganisms like fungi and yeast to create this gaming environment. So in a nutshell, this is a mold rush that allows players to watch the slow growth of these mold patches on the internet, which is being live streamed, and placing bets and kind of educated guesses of how the growth would pan out. So peer players would actually pick certain parts of this grid to actually guess or predict where the mold would actually grow. And you can play a very interactive game where you can decide to kill or destroy another opponent's patch by ordering the moderator to actually inject chemicals to these mold patches to kill these microorganisms. So it sounds a little bit garish and quite unusual, but it generated a lot of interest, at least on gaming platforms like Twitch, where people were fascinated to wait and look at the mold growth over many days to play this strategic game. And again, you can read more about that with a paper I published in 2018. But what I want to, the basic point of this research was that if we are designing interactive systems with living materials, the temporalities could actually become one of the key points of elevating user experiences when we are interacting with microorganisms. So mutualistic care is the second pillar of the living artifacts paradigm. By design has been traditionally been very extractive, meaning that it's very human-centric, and a lot of engineering and scientific research has gone into creating systems that are very extractive, meaning that it's sometimes very harmful to the environment and causes harm to the organism that are being interacting and being part of the product in a very negative way. So mutualistic care proposes a slightly different way of thinking. Whatever design we create, whatever frameworks that we work with, it has to benefit the both parties that are the microorganisms and the human beings as well. One of the great examples that illustrate this idea of mutualistic care is a robot called NukaBot, which was published in 2021. So this is all about caring for the microorganisms that are living inside food materials. Let me just quickly run this video. So this robot is a fermenting robot that allows food to be fermented. But this is not just a traditional food fermenting vessel. Inside the vessel, there are many sensors that detect microbial activities. So if the microbes are not performing that well, it actually relays that to the user of the robot, and it has a voice interaction, so the actual robot can speak for the microbes themselves. There's a lot of anthropomorphic elements here, humanizing the microbes, humanizing the invisible nature of the microorganisms to really bring about how they are feeling, how they're behaving under these conditions to provide you with the fermented food. So it's a little bit of a twist on the Japanese culture. I believe that this is a very much traditional way of producing food that are fermented and preserved. So these researchers were really interested in how could we actually pivot from a traditional fermenting vessel, which are very one-way street in terms of communication. How can you talk to microbes? How can you empathize with them? And how can you help them to actually grow and flourish and at the same time provide us with a savory food? Yeah, and habitabilities is, I would say, the last and the third pillar of the living artifacts paradigm. So this is going back to the basics of the environment and thinking about where these products or artifacts could be produced. Traditionally, again, at least in biological research, we now have this thing called a petri dish, fermentation vessel. It's all about containment, isn't it? It's all about how do we contain this organism so that you can force them to do what we want to do, want them to do. So it's very kind of a human-centric and very aggressive way of working with living organisms. Habitabilities, in a similar way to mutualistic care, flips that on the head and thinking about how we can work with the habitabilities of the nature and living organisms that are within it. Caraval is a slightly conceptual robotic interaction project done by Ivan Henriquez, which I think displays the essence or the value of habitabilities very well. So this is the robot that is powered by bacterial activities that are happening inside the pond. So essentially, the robots are being driven by the bacterial activities themselves. It's not operated by batteries or any artificial means of energy. And what it does is it actually cleans up and cleans up the pollution inside the lake or the river or the pond that these robots would be habiting. So the idea here is to create habitabilities that are synergistic, not very extractive, but working with the environment that are naturally found within these microbial habitats. So another framework that would help designers to work with sustainable living materials is this idea of surfacing livingness in microbial displays. So this is the research I want to share, which I think is very important for biodesigners at the moment. It's the research I did at when I was at TU Delft with a group run by Alvin Kerana. And this is a very practical guideline of how to use living artifact pillars in a efficient way. So we talk about livingness in sustainable materials. This is the starting point of our exploration. So livingness is defined by this condition or a quality of having life and being alive. So if we observe nature, nature does not stand still, as I said. It moves, it changes color, I think the top right-hand one is like a very exotic bird in the jungle. It creates these movements with bright colors to attract different mates. There's some crowd behavior going on the third image here. Um, there's this idea of crowd behavioral controls. There are sounds also that's been made by these frogs to mate. And again, with these slime molds and microbes, they are also changing at the same time. So essentially, what we're saying here is that living, this quality of living, um, is and one of the main elements that designers should work with when we are talking about biodesign. So what we are trying to propose is that microorganisms are very difficult to detect their livingness. I will quickly run different examples of why microbes are very hard to detect. But essentially what we are doing is to surface the livingness of microorganisms that are very hard to detect. There are many examples. I'm not going to talk all of these projects, but these are some of the key research projects that's been observed in design. Yeah, so with microorganisms, unlike plants, if we look at plants, if they are not happy, if they are dying, or if they are um, devoid of water, for example, it it tells you, right? It shows it displays itself in a way that's very indicative. So if I see a flower that's wilting or a plant that's not shriveling, then I kind of know through my senses that this plant is not doing well. In the animal kingdom, dogs might wag their tails if they're happy. They may hide their tails if they're scared or if they're sad. So you get the picture. There are many ways that these big organisms that are visible that can show you how well they're doing in terms of their livingness. However, uh, microorganisms, which are the predominant players in biodesign, they are notoriously difficult to detect. And if we don't find them very detectable, it's very difficult to understand their behaviors and to create designs that are sustainable. One example is that this is a very obvious example, bacteria, yeast, and things like that. They are very small and they're microscopic. So they'll be very difficult to see and visualize and detect how they're doing. Like fungi, for example, or mold, they're incredibly slow to grow, at least from a human scale. So thinking about their temporalities, um, like electronic objects or digital artifacts, they're incredibly responsive, but organisms like bacteria do not respond in that way, at least from a human level of sensing. There's also the social and cultural aspects of microorganisms that they're seen as something that's negative. Traditionally, it's been related to disease and pandemics. COVID pandemic didn't help really. And the perception is that they're very negative. So in some ways, for the design community, it's not something that are being welcomed with open hands, although mycelium and bacteriocellulose communities are growing very strong at the moment. And like I said earlier about COVID, some microbes are pathogenic, obviously. It's a very, very tiny percentage of microorganisms that are pathogenic, and that would deter designers to work not with organisms, microorganisms like bacteria, but with something else that's non-living. So what we are designing here is to create a taxonomy of surfacing mechanisms. We sat down in Delft and said, okay, bacteria are very hard to detect. What are the mechanisms we can design to allow their livingness to surface? Yeah, how can we allow them to detect their physiological and chemical well-being, and how can we allow these mechanisms to be integrated or baked in into the design process itself. So what we did was we scanned probably a few thousand artifacts, designs that integrate microorganisms or implicate microorganisms in some ways into their products or services, and to analyze into different mechanisms. From thousands, we narrowed down to 45 living artifacts to be analyzed deeper to create these mechanisms. So we identified, we named and ordered different surfacing mechanisms that designers can actually borrow to create their designs. I'm not going to talk too much about the analysis side of the things, but we divided it into 6 different mechanisms of surfacing livingness, which I will talk and unpack in a more detail in the later slides. So essentially, we came up with 6 different mechanisms of surfacing. First one is canvassing. This is an incredibly basic notion of providing a canvas. I know it sounds very conceptual. To the scientists out there, this is completely alien. So traditionally, like I said, with petri dishes, it's a form of a canvas, but it is actually a design decision to create a basic platform where microbes can grow. So the canvassing mechanism could be simply laying out a layer of an agar, which is a semi-solid platform for microorganisms to grow. This platform would have some nutrients. It would be semi-solid so that it provides a semi-permeable interface where the molecules and chemicals could actually interchange with the microbes that are living on top of it. But there are many types of canvases you can think of. You can even think of a pond or a natural environment or even a country as a canvas, going beyond the confines of the laboratories, beyond the confines of fermentation vessels and petri dishes. Okay, so this is a basic way of thinking about how to start a biodesign process, is to simply provide a canvas for microbes to flourish and for us to notice these living things. So there are lots and lots of canvassing examples that are found in human-computer interaction and also in biodesign. I'm not going to run through all of these examples, but some of them were very interesting examples. The second example from the second row is this idea that the canvas does not have to be glass or plastic that are very commonly used in science, but also in bio art and design. If we treat this canvas as with a different material like wood or a satin finish, it might provide a slightly different perspective of how microbes are surfaced and perceived. And you can also think about different scales of the canvassing itself, like I talked about earlier. But again, I'm happy to go over each of the examples of the canvassing in later detail. Level 2 of the surfacing mechanisms is marking. Again, this is a very humble and modest design intervention, but we found it very useful to think about. This marking is the sourdough marking. So this is a traditional way of hot DIY-based microbiology experiment, shall we say, of making bread. If over time the microbes in the sourdough rises due to the gaseous production, this would actually create this visual change of the livingness of the microbes that are fermenting in the sourdough mixture. Marking is a design element, is a graphic design element that you can simply deploy to create this illusion of change, to surface this tiny change that's happening in the sourdough to the tangible and surfaceable level. but you can think about other types of marking. Digital marking is a very good example of how we can track, monitor, and surface the livingness of microorganisms. Like I said, things like slime mold and bacteria, they're very slow growing. So by digitally monitoring these things, making these trail marks on the above example here, is to create the livingness visible through digital means and digital overlays. And with the bottom example is the mold rush example where I created these digital overlays. It's almost like a gaming environment with these kind of overlay digital graphics to indicate different types of life cycle stages of the microbes that are being implemented. There are different types of marking. I'm not going to go through all of these again, but markings are very useful and very non-invasive way of marking the surfacing the livingness of these microorganisms. Okay, now we move to level 3, which is the idea of magnifying the microorganisms. Again, this is a classic device used in science to observe the kind of a quotation mark, the unseen world of microorganisms. It's a simple magnification would allow us to visualize and to notice these organisms in action. One key word I keep mentioning is this idea of noticing. This is actually a term I borrowed from post-humanist scholars like Anand Singh, who used this word noticing as a means to be one with the nature and be less anthropocentric, and be a little less humanistic in terms of how we look and interact with nature. And there are many magnifying examples, obviously, at least in science, but also in design. Maud Rush used high magnification to bring about this gaming environment involving molds and yeasts. Level 4 is translating. So this is the way to translate the unseen activities of microorganisms. A classic example of translation is to use this kind of pressure pumps or pressure gauges to actually detect minute changes that are happening in a fermentation vessel. There are other examples in the digital realms. You can translate microorganisms using code. So this example here, the very first one, let me rewind. So this is a project done by Matt Kenyon all the way back in 2011. This is the idea of translating and humanizing a microbe called tardigrade, which is the water bears, and creating a digital character that can be animated according to its behavior. And then we have here evolving game terrains. So this idea that you can digitize fungal growth and translate that into a digital gaming platform. The very interesting examples of how the slow growth could be translated in a digital way, which then can be sped up in a very interactive format here. But more, you can read more about it in this paper here, but in 2015. And obviously, I touched upon the Nucabot example of translating the fermenting microbes into humanistic form. This is the second example. It's called Alice, and this is the idea to beautify and make things colorful based on the microbial activities. So this is one of the snapshots of an interface that they designed. So they created this visualization of how microbes are doing in terms of growth and their behaviors. So it's a very colorful and interactive experience if you go to their website. Level 5 is nudging. So nudging is the way to literally physically intervene in terms of, I would say, not just waking microbes up, but physically stimulating these microbes to behave in a way that's surfaceable. So the first example here is the way that you can shake a glass of bioluminescent algae. Without it being shaked, these are invisible, but the mechanical shaking allows the organisms to glow in this way so that you can notice their presence. You can also nudge them using um, light stimulation. Certain microbes that are very sensitive to light, so they tend to shy away or swim away from the microbes. So this is an interesting example where they created an interactive gaming platform where people could control the direction of the light on top of the dish where the microbes are to create this movement. I would say a forced movement for the microbe to act. And you can also nudge them using food. This is an example of a slime mold. Um, so these tiny letters, alphabets, they are actually made out of oats, which is the food for the slime molds. And you can create some sentences and words that are spoken um, by these slime molds by allowing them to go to these words that are essentially food materials. It's almost like a perverse game of Ouija board, I would say, allowing these microbes to swim across into different letters to spell out certain words or sentences.
Normally, if you want, at this point, we can have a little break. Yeah, maybe like a 10 minutes or so. I don't know how much things you have to say. I
Yeah,
mean,
yeah, I have two more
is it okay to
slides. Yeah, I have
two
two
more?
more slides.
Oh, okay,
Yeah.
okay, fair enough. You go
Yeah,
ahead.
yeah,
Yeah,
I'll
sorry.
wrap it up in 1 minute.
Yeah,
So
that's
that
okay.
the
Take your time.
yeah, so this is the last level, which is the molecular programming. It's the idea that you can program and genetically modify organisms to, let's say, change color or behave in a certain way, which is very pervasive and intrusive, but it's one of the ways to engage with the microorganisms and their worlds. So these are the 6 levels of surfacing livingness that designers can use. And there are many other examples I can share later on. Um, yeah, so the main contribution of this research was that the surfacing mechanisms, we can actually create 6 levels of mechanisms, and these are adjustable and adaptable. And you can also think about it in terms of uh, post-humanist idea that so going from the level 1 is the most non-human centered approach, and then the level 6 is probably the most extreme, yeah, the most harmful way I would say of interacting with microorganisms. So it allows designers to choose which levels to start with, which levels to adjust, and to contextualize their research. And last but not least, you can also check out our company's work on this website, and you can subscribe to the free newsletter. So yeah, so it's a bit of a transition at the moment. We are now focusing more on B2B, so business to business, focusing also on AI and molecular design levels. So it's a little bit different in terms of physical, tangible materials. This is a new direction for us, but we still want to run the newsletter for the students and academics. So if you have a moment, please sign up. We send weekly newsletters, and yeah, we can talk about what we offer and what we teach in these newsletters as well. But with that being said, yeah, that's it for the first part. And yeah, we can also have a break and can come back with more questions if you like.
That's great. Oh, thank you so much. No, that was really, really interesting. It was good to actually to see how you contextualize some of the projects that I've
Mm,
seen some of the projects here and there, but I didn't
mm,
really have any kind of sense of taxonomy. So that your taxonomy is actually quite
yeah,
interesting. And I've been
thank you.
using the word translation quite a lot, but with a more sociological connotation. So I will be using
Mhm.
some of the example used there as counterexample of what I'm trying to say, somehow to help me
I see.
illustrate that I am going a different pathway here.
Yes,
But
indeed.
that yeah, no, that's really, really good. Yeah. I reposted the
Mm.
you were talking about a paper at the beginning. So I posted that on their
Oh, great.
iLearn website. Yeah, but that's I think that's the paper they presented in Taipei actually,
Oh, yeah,
or was it
yeah.
not? But it's on
Yeah, they're
there's like a design
becoming
journal.
microbes.
Yeah,
Yeah.
yeah, that there's a design journal that is from Taiwan, and that's on their
All right.
website that I found it. So,
All right,
and
right.
then
Yeah, I mean, yeah,
with
I've been
Elisa Jacardi. Elisa
involved in
Jacardi is
several
one of the
projects,
writers.
so it's a little bit confusing, but yeah,
Yeah,
I
no worry,
suspect
of
so.
course.
Mm.
That was funny that it was actually on that website. I thought, well, okay.
Yeah.
That was
Good, good.
there. That was an interesting reconnection somehow through the movement of
Yes.
people in the world. We are microbes. We are giant microbes, aren't we? Uh,
Yes.
okay. All right. Well, thank you very much. Let's meet again in like 10 minutes. Is that okay? So you have
Yeah.
a time
Yeah,
to
no problem.
everyone's got a bit of time away from their screen. I think
Yeah.
that's the point. Don't do not stay in front of your screen too long. And
Yeah,
then
no
yeah,
problem.
around so I'll open again around 7:34. There we go, to
Yeah.
be precise.
No problem. All
Thank
right.
you. Talk to you
Okay, see
soon.
you another
Thank you
day.
very
Okay,
much.
bye.
I'm just checking on my family a little bit as well at the same
Yeah.
time.
All
I'm at
right.
home.
All right. Okay.
All right. Okay. Good. I mean, thank you so much. I mean, this is really, really interesting, and I
Yeah.
really enjoyed so far what you
Thank you so
had
much.
to talk about. That's good, and I really like this new kind of taxonomy. The thing is, we are using those words in such a different way. When you talk about habitabilities,
Mm.
can you explain a
Yeah.
little bit more about this idea of habitability? I'm not sure I understood your perspective on habitability. So you have this machine kind of
Yeah.
waiting for an alga to develop and using the energy of the algae
Yeah.
to move
Ye-
itself. Is that what you're saying?
Yeah, with the yeah, so habitability is
Yeah.
just a lens for us to think about yeah, what are the habitats and environments
Ah,
of
okay.
where these organisms operate, really.
Okay, okay.
And then there was an example of how habitabilities have been interpreted.
I see.
So that robot was a self-driving robot. So it's
Okay.
not driven by any artificial means.
Yeah, yeah,
It
yeah.
what it does is it just houses these the algae colonies inside the robot,
Okay.
and so that itself generates the microbial fuels. Then that would actually
I
power
see.
the robot to move across the pond.
Okay, okay, okay.
Um, so the main point I was making there was that habitats do not have to be confined in a laboratory space. It
Ah,
can be something that's created to work with nature, like integrated
yes.
within the natural environment.
Okay, okay, okay. That's the interesting part. Okay, okay. Because
Mm.
in architecture, the word habitability is being used a bit differently because this is where where architecture and psychology touch one another.
All
So, for
right.
example, so I do virtual reality. That's my approach to architecture and architectural
Hmm.
design, and we use the planet Mars, the moon are kind of places where a lot of architects have made relatively interesting proposal in terms of material, most
Hmm.
of them.
Yeah.
And that's one thing, but not so many people have been kind of thinking about the habitability of such a place. And
All right.
while it might be not so critical for the moon, I think it becomes absolutely critical when you're
Hmm.
living on, we plan to live on Mars at some point,
Yes.
because you're 6, 7 years away, or 6, 7 months, sorry, away from Earth, and with the possibility of not even being able to come back. So it
Hmm.
might be just a one-way
Indeed.
trip. I don't know if you remember,
Yes.
there was in I think 2018, there was a group called the Mars 101 in England. I don't know if you ever heard. There was a group of people,
No.
some of them being actually, smart people, being kind of teacher at Cambridge and, really well-respected places. And the idea was that, oh, okay, you know what, we can actually embrace this idea of going to Mars, and then rather
Mm.
than kind of leave it to the NASA or the ESA or the Chinese
Yeah.
equivalent to say, well, we could kind of find some sort of agreement and have renting a spaceship
Mhm.
and go there and start a life there. It was a really
Yeah.
fun project. I had some student interviewing some of the member of that group.
All
So we
right.
were trying to make design in response
Hmm.
to the design. What the thing we were really worried about is the habitability. So rather than kind of the
Hmm.
tech, I look at the ISIS is like it's rather kind of uninhabitable. But then some
Hmm.
people we kind of presented project where, oh, let's make music inside. There
Hmm.
was this lady, I don't know if you remember this Italian lady who said, let's make an espresso inside.
All
Do you
right.
remember that example? So
No, I mean, to be
so
honest, I've
yeah.
not been very kept in touch with the space explorations, to be
Oh, I
honest.
see. Yeah.
But yeah,
Yeah.
I can imagine. Yeah, that. Yeah, I can imagine her doing that.
Yeah. I mean, it's
So
because
what was the crack? What happened?
no, no, finally I wish she was Italian, and she managed to negotiate with a big Italian company to actually make an espresso machine that would work on the ISIS.
Oh,
On
okay.
And we're just kind of okay, you know. And I think we can kind of take this project as a bit of all right, a bit extreme project, but at the same time, I think what she does is something really simple: is to say, let's
Mm.
improve the habitability of the space. Let's kind of
Mhm.
let's not distinguish that space from the kind of normal space we have, not in terms
Yeah.
of luxury, but kind of thinking, well, living in space is a stress in itself, and we
Yeah.
should kind of be thinking about the architecture in psychological
Mhm.
terms. That's what it is about, really.
Yeah.
it was a bit a
It'd be
way of
nice to,
reconsidering the
yeah,
space. Yeah.
yeah, it'd be nice to think about virtual reality also, how that could be
Yeah,
implemented in space exploration, whether you can actually simulate or training environment for these kind of explorations. I don't know whether you're interested in applying VR to that kind of context.
yeah, yeah. I mean, this is one way you can do it. You can you somehow you've touched on this on the topic of there was whether you use VR as an instrumentalization. Say, oh, I want to do this thing, and like you say, VR become a simulation of that situation, or
Mm,
allows people to live situation of stress. Like we're talking about firemen creating a smoke area and putting you in that kind of situation, see how would you will react and things of the
mm,
sort. I'm trying to move. I'm very Latourian on that. I don't know if you know Bruno Latour. We are kind of moving to much more of the technology as a mediation,
mm,
where we kind of accept that we shape the technology, but also that the technology shapes us in return. So
mm,
I'm kind of
yeah.
I'm doing this kind of dual movement. So
Mm,
which means that in terms of planning, we kind of start thinking about, okay, well, if you want to kind of create a sustainable space in the middle of the desert, for example, we had
mm,
last year, then we kind of start thinking about where we would put the windows. What do we
mm,
see? What do we need to
mhm.
see?
Yeah.
And how do we wake up?
Mm,
What wakes us up?
yeah.
How do we meet? So we can start really rethinking this space. You could
Yeah.
say in terms of habitability, but I think in terms of
Mm,
mediation here as well. So the
yeah.
space, the architectural space is not there only to serve the user. It's also there to actually teach or remind or orient
Mm,
its gaze. I like to use the word
yeah.
gaze in that situation.
Yeah.
So, yay, the feminist. You were talking about Anna Singh, you know.
Yeah.
So I think
Yes.
they definitely they're there to kind of teach us something back about the
Mhm.
way we look at things, or the way
Yeah.
we look
Yeah.
at
Indeed.
others. As simple
Mhm.
as that. Of course,
Yes.
that's the whole idea.
Yeah. I mean, I love
Yeah,
to
yeah.
learn a little bit more about your research also. If you want to share something maybe later.
Yeah, yeah, of
Yeah.
course. Yeah, yeah. That was great pleasure. Yeah, I'm trying to kind of
Mm,
assemble some of the work we've been doing with students into a work. But I personally
yeah.
work with Stanley Kubrick. That's the Kubrick archive. That's where
All
all of
right.
that kind of stuff. So that was really funny because I was 5 meters away from the Kubrick archive at LCC, as you may know. Did you
All
know we
right.
had the
Yeah.
Kubrick
Yeah.
archive at
Yeah. I heard
downstairs?
something about that. Yeah. Yeah.
So it was very easy for me to go downstairs doing my research over
Mm,
there.
yeah.
Uh,
Yeah.
and I took like five kind of objects from him,
Mm,
and I started kind of using those objects in terms of reflection. He has a
yeah.
way. I mean, I didn't know I would be successful in writing
Mhm.
that PhD, I have to say. I did ask that
Yeah.
question many times. They were really pissed off by my question. But I was like, I really don't know where this is going to go. But I found this object, and then this object really kind of triggered a lot of conversation. Then I was
Yeah.
managed to get back into STS, Science and Technology
I
Studies.
see. Yeah.
So there was a whole
Mhm.
conversation about
I
our
see.
relation to object, which is
Right.
not looking at things, but how the object
Mhm.
look at us at the same time. Might be interesting in your situation somehow to kind of
Yeah.
looking
Absolutely.
at those because you're really on that border with you were again you were talking about that thing you're on that border with kind of engaging with a more feminist
Yeah.
perspective.
Yeah.
And I really like the word noticing. That's such a
Mhm. Yes.
or the word figuring, which is another one that comes out
Mhm.
from that group of women. So
Absolutely.
yeah,
Yeah.
yeah. This is not the topic that is very hot here, but that's all right. That's all right. I think
Yeah.
it's a really important one. Yeah,
Yeah, I suppose
yeah.
yeah, it could be a cultural then shift, and
Oh,
also I guess it's good in a way that you guys can be one of the yeah front runners of this movement, post-humanist, more than human. I don't know what you call it these days, but
yeah, yeah, of course,
yeah.
of course. Yeah, yeah. I was on a talk. You know, Nortier Maris. Nortier Maris. She's teaching at Warwick University. She did a
Oh,
talk
okay.
this Monday at Aalto University. That was online. So whenever there's something online, I'm just kind of go and have a bit of a
Yeah.
look. Yeah,
Yeah.
I mean, she mentioned some of that kind of how maybe the more than human is actually still too utopist
Mhm.
in
Oh,
the way
yeah.
they look at things.
Yeah, I
Uh,
agree with that.
yeah,
Yeah.
Yeah, and then sometimes I think that's and maybe that's the thing you complain you were saying about speculative design is the kind of
Mm.
utopian look at things where somehow you get
Yeah.
so detached from reality that at some point it doesn't matter so much. It's really
Yeah, yeah,
it doesn't go back into the loop. It's not helping in
yeah,
any way,
absolutely.
shape, or form. Yeah.
Yeah, yeah, indeed, indeed. And yeah, and with this the
Mm,
emergence
mm.
of the AI stuff, it's everything's kind of up in the air at the moment, isn't it?
Yes.
Nothing's certain, nothing's
No.
credible anymore, nothing's
Yeah.
real.
Yeah, I know. But that she mentioned that's the post-normal era we are. And I think, Dunn and Raby probably were some of the first in design who actually managed to
Mm,
talk about the post-normal. I remember reading that for the
yes.
very first time in one of their early books.
Mm,
It's like, was it
yeah.
Edson Tales or
Yeah,
the
could be.
speculative one, I think. Maybe I forgot. It's one or the other.
Yeah.
But but
Apparently, yeah, I heard.
yeah.
I also they wrote a new book and it's
Yes.
translated in Chinese,
Ah, okay. Oh, good, good,
so
good.
it might
Yeah,
be something
okay.
for the students also.
Yeah, sure.
Yeah, it's
I don't
called
think we
Not
have
Here,
reached
Not
that
Now,
point
I
yet.
think. Yeah.
Yeah, yeah, no, no, I've got a copy in English in my office. Don't worry.
Right, right.
But yeah, I think not here, not now yet. That's a
Indeed.
response. But maybe at some point. Yeah, yeah,
Yeah.
yeah. I will talk about that later. Okay, sorry.
Yes, of
This
course. Yeah,
is
yeah.
this is your time, and actually, I want to listen. So more than I want to talk. Thank you so much again.
Okay, no problem. Yeah. Thanks, guys, for coming back. And what we'll do the second part of the talk, and we can also have some time to discuss a few things. So let me share the screen again. Then, yeah, so I just want to quickly share something from the Byteson Academy. So look, listen, like I said, what I've been talking about is pretty much traditional conventional by design in the purest form, involving not AI or any type of machine learning. But this is the way that we are thinking about at the moment with the new direction with AI. So this will be the basis of the talk I will give next week, how AI can integrate into by design and sustainable materials development. And here are just a few articles that I've been writing about. If AI could be used to generate new types of materials that are not seen in nature, that are completely artificially generated, what does it mean? How designers could use AI in this way, and what are the ethical consequences that people need to think about? And there are tons of resources. I can also share my past presentation notes. Also, you can also go to, these are all open for you to access. Yeah, and there are many opinionated pieces also. I have tons of toolkits, yeah, frameworks that you can use, vocabularies, interactive games, and things like that. So feel free to check it out after the talk. And if you have any questions related to this, I'm happy to discuss as well. Um, the whole point of this part of the talk now then is, okay, so AI is really hyping up at the moment, and there's a lot of noise in AI. And then there's the conventional biology. So what does it actually mean now? How do we bridge this gap? Yeah, and this is the part I will quickly discuss in the second half of this talk to really think about how the digital intervention have been shaping by design over the past decade. And what we do is we're going to talk about by digital interfaces. So this digital interfaces it's not new, obviously, in computer interaction. But more recently, in the past decade, this idea of creating a hybrid interface that allows communication between the biological and the digital world is becoming more popular, not least because of the commoditization of the electronic components and opening of the code sources, and also biotechnological facilities, equipments, and cost of running a lab is becoming cheaper. So this is natural merger of the digital infrastructure with the biological world. It's still at the margins of the mainstream design research, I have to say, but over the past decade, it has grown quite a lot with large groups of and communities that are coming together. And like I said, it bridges the gap between living systems like cells, tissues, and organisms and computational processes. And this allows for hybrid modes of sensing. Now we are talking in the realms of interaction design, of sensing and actuating, control and feedback, this kind of computational notions that are being overlapped in the areas of life sciences. So bidigital interfaces, the terminology really was born back in the 1950s when they started to develop this idea of bidigital medical applications. Many of the technologies stem either from the governmental developments of the technology or in the medical sector, which is deemed to be more urgent and more pressing. So this is one of the earliest, what we call a biodigital product, Siemens Elima cardiac pacemaker. This was 1958. They actually first time in the history of humankind to, fit a pacemaker that's driven by electricity to work in sync with the human physiology. There are tons of other examples. Obviously, there are cochlear implants that does a similar thing with the electronics and the human body. A little bit more recent example, I would say, is the brain-computer interface. The fact that you can actually measure and actuate the brain activity to the computational interface was a huge development many decades ago. On a diabetes level, there are many sensors, like they detect glucose levels in the human blood. So quite a standard mundane examples here. And then MIT have recently looked into how we can create wearable sensors that detect human sweat and the chemicals within these human sweats and bodily fluids to communicate through the digital interface how your body is reacting and behaving in a certain environment. So for the purpose of this talk, for brevity, I will focus on not the human body, but the microbial interactions, because most of the sustainable materials that are being developed focuses on this particular kingdom of life. So whether it's E. coli, the bacteria, which is actually the standard workhorse, or they call it the workhorse of the modern science and synthetic biology. And slime mold is a very interesting example from a biodigital interface point of view. Slime mold is a very intelligent organism, I would say. It computes and assesses how to navigate the forest floor through calculating and computing where the food sources are and figuring out the best pathway for them to grow and move across the forest floor. So there are many research groups out there. One really interesting project I heard was this project called Wood Wide Web. So borrowing the analogy of the World Wide Web and thinking about mycelium and other fungal creatures to create communication networks that designers can benefit from. I can also share a link for that research as well. So organisms are used as not just a passive biological material, but as a computational material itself. So in the earlier talk, I talked about living things as design materials. Now we are moving into the second phase, which is to think about living things as computational materials and also computers themselves, which is a very radical shift of how biology is perceived. And again, this is a very timely topic to talk about, especially with the emergence of AI and how that could be implemented in design as well. Yeah, and one of the paradigms to think about is this idea of agents. Agents is a very loaded word these days, especially in AI. But you can also think of agents in terms of microbial species and colonies. So these have their own separate intelligences that are separate from humans and possibly artificial intelligence as well, to kind of interact together in this kind of three agent process. which does, I have to say, complicate and yeah, make the relationship very fraught with ethical consequences. But it's nevertheless a very exciting paradigm to think about and to do research in. So the most basic and mundane example of biodigital interfaces is this idea of creating these environments that are digitally controlled. Um, Again, this is a very traditional way of using biodigital interfaces to kind of monitor and sense the microbial activities of the fermentation vessel. This is a very commercialized setup. The huge vats of fermented vessels with nutrients and microbes growing inside. So this could be a typical layout for fermentation and beverage companies like beer making companies to use these things to compute and digitize the microbial activities for commercial profit. And biosensors is one of the elements within the bioreactor that literally is the biodigital interface to sense different types of environmental changes within the vessel and to actually monitor and track the microorganisms that are inside the vessels. So there are many types of digital interfaces. This is the very basic, mundane example that I just want to get out there first. And then in terms of the elements of these biodigital interfaces in the bioreactor, there are many different types, which I won't go into too much detail. But yeah, these are the components of the designs themselves with their own fields and research communities to think about. Yeah, and these are some of the images of the digital interfaces in a commercial sense. I think the one on the left is pharmaceutical fermenting vessel to calibrate and monitor different types of pharmaceuticals being produced. And the second one is the scaled up version of more like an industrial bioreactor to use computing power to actually predict and detect microbial activities. One interesting side note on this is what they're doing at the moment with AI is that they're using GPT to actually communicate with the microbes. So actually leaving the humans completely out of the picture. So they're deploying multi-agents to communicate with the physiological changes of the microbes and then actually automate the process to keep the cultures alive and also to produce these goods, if you like pharmaceutical products and possibly food and drink beverages in the future as well. So from a modern development technological point of view, this is a very interesting area that these industries and mass-produced products would no longer involve humans at all if this would become autonomous and self-reliant. And I will talk more about autonomous laboratories and autonomous biodesign more in the next week's lecture. Sometimes you can also create these environments yourself using open source materials like Arduino. I think this one is open source, so you can download code and run these environments yourself. I would say that with the use of things like Claude and ChatGPT, you can also create your own code. Nowadays, nobody writes codes anymore. It's all done by the computer. Nevertheless, the point is that there are many open source materials out there for you to explore as a designer. And I would say, as a designer, there's no better time to be alive with this kind of open source and accessible materials, which opens a lot of opportunities for people to explore. When I was doing my studies many decades ago, well, a couple of decades ago, we didn't have this, and we had to rely on expensive materials and also working with people that are in very exclusive environments, which didn't bode well for creativity, I would say. But these are some of the links that you can check out. Yeah, and then the rise of the smartphones obviously made interaction design more accessible, especially with DIY setups like this. I think I mentioned this earlier in the talk. So this is the idea to create this kind of gaming environment to interact with microorganisms using your smartphone and then light control with a joystick. So again, ethically, this is a questionable project because what you're essentially doing is you're stimulating microbes in a negative way, so that they would allow or force the microorganisms to swim away from from the light source. And then what this designer have done is they created a digital overlay to create a Pac-Man game that would represent this microorganism's movement. So the idea is to control and steer these organisms using light to create this digital environment. If you want to check it out, if you want to make a digital game for yourself that interacts with living organisms, the full protocols, all the materials you can get are laid out here in this link. And again, you can also modify this by customizing the code and helping you to decide what type of designs you want to create. So this is the beauty of open source, is that you can also bake your own values into your design, whether it's going to be more accessible to people or it's going to be more forgiving and more understanding for the non-human world. That's really up to you. And I think the open source community really helps with this process. And this is another example I mentioned earlier in more detail. So you can actually create a digital map. So this guy scanned a mold growth over many days and then digitally rendered it. So I would say this is another form of virtual reality. It's not run by code per se. This is actually run by the organisms themselves, these shapes and these ridges that are being created by biological processes rather than the digital codes. So it's a very interesting perspective to think about when we are creating virtual environments. They do not necessarily have to be originating from code, but originating from the code of the life itself, the biochemical and the reactions that are necessary to produce this growth. So yeah, it's not a new project, 2015, more than 10 years ago, but it's a project worth checking out. Again, they provide all the materials and protocols so you can actually implement this type of methodology to your own design work as well. Even for architecture, you can actually think about scaling up these growth patterns in an architectural context. And here is the link, and I'll share the PowerPoint presentation also. You can have the direct link. Yeah, and then we can talk about the microbial care. So this is borrowing the mutualistic care pillar that we talked about in living artifacts. So this is a project called Tardigochi I mentioned earlier, but in a more detail. So these researchers were interested in how do we digitize water bears that are found in moss and pond water. Some of you might be familiar with this word Tamagotchi, which I believe is a Japanese word, and it's basically a digital pet toy you can carry around. It was very popular in the 1990s. I'm not sure whether it's making a comeback these days, but the idea is to create a two-faced toy. One is a living toy, which with the real water bears inside. So on the left-hand side of the sphere is the actual organism with the biological functioning. And then the second side is the digital side to create and translate how the water bear is feeling. So if the water bear is hungry, you can actually create a digitized robotic arm with a needle attached to feed these water bears to make it happy. It's a little bit tongue-in-cheek, I would say. I'm not sure whether this is a real project with a bit of speculation going on, but you can actually use, networking facilities to actually send emails to interact with the user, sending an email of how things are doing in the microbial world. And then you can also interact with it using some type of networked artifacts. So it's really interesting because this was a project that was done in 2011, so more than 15 years ago. And now things are also happening in the mainstream media with AI, creating these things like agents, agentic workflows, which is super interesting to think about from a biological point of view. AI is doing the similar thing, but microorganisms and biological things that have their own intelligences, they can also participate in this framework as well. So we can think about multiple different types of intelligences and how we can actually navigate multi-agentic systems involving humans, computers, and non-human living systems like microbes here. And again, they detail in great lengths to talk about the components used, how they are being designed. Yeah, again, I'm not sure whether people want to design these kind of things because in some ways it's not very, yeah, it's very human-centric, isn't it? This idea of capturing and containing and confining organisms is a very human-centric point of view. So yeah, I suppose the door is open for people to interpret what these could do and kind of outweigh and balance what is good for the organism and what's not, and make your own decisions on that. And the new cobots, this is just a more of an unpacking of how these things were designed. So on the left-hand side, they have this what they call the monster eye. Some of you may be more familiar with this kind of Japanese culture. Um, I forgot the word they call it. They call it this kind of a monster is cute kind of analogy. So they have this terminology where if you put like a massive eye on something and it kind of looks like a monsterish, but then you kind of balance it with the cuteness to create this kind of yeah disarming kind of aesthetic. And they really played hard on this idea that you can create a cute monster that becomes like a microbe in some ways. So this eye is like an interactive eye. So when the microbes are hungry, these would actually blink to the user to actually communicate to the user that the microbe is hungry. And you can also speak to it. It's a speech, like a voice interface. You can actually speak to the microbe, and then that gets interpreted or translated in the actuator within the vessel. And you can also control how the fermenter vessel is operating. So if the microbe needs a good stir, the robot actually speaks to the person and say, "Hey, I'm really not very well. Can you give me a stir?" And you can actually stir the organism, and then they can reply back that they're happy. So it's a very playful. Many people would say this is quite kitsch, like it's not that serious, but I think it's a very interesting example of starting to think about microbes not just as a workhorse or some type of a material that can provide for us, but it's something that we can interact with, engage with, and even have a relationship with. And again, there's a kind of interesting parallels with it with robots and robotic development. If you can have relationship with robots, can you also have relationship with invisible and intangible things like the microorganisms that are presented here? Some more biodigital interfaces that are being researched at the moment. People are talking about smartwatches these days and how you can create Fitbits and monitor your health, digitizing your health, and creating a kind of a network system to monitor your health. But these designers from Chicago University, they wanted to produce something a little bit different in terms of how we interact with the health technology. What it is a smartwatch run by both the digital interfaces and also slime molds. So it is a watch that contains the digital programming, but also living slime molds. And how it works is that there is a connection port. So the wire is becoming the wire that connects the watch is the slime mold. So the slime mold's movement from one area to the other, from left to right, would actually turn on the smartwatch. So the idea is that to look after and take care of these microorganisms by feeding the food would then actually allow us to monitor our own health and to reflect on how we actually can improve our own health at the same time with the microorganisms. Again, it's a little bit conceptual from a commercial point of view, but it does raise questions about how we can notice and also care for the microorganisms whilst we take care of our own physiological well-beings as well. Again, this can be construed as a little bit um, less commercial in some ways, but I would say this is more of a critical design for us to force to think about our relationship with the unseen world. And this is Alice's example with the visualization I talked about earlier. And then I just want to kind of finish up by talking about the future of biodigital interfaces. Of course, the rise of agentic AI, machine learning is the way to go. But there are other types of modifications of how digital infrastructures could be made to assist in biodesign. And here are some of the non-AI examples that we could think about. So you may have heard of the term biology is the new digital, thinking about how DNA molecules could be digitized in a binary format. And one of the big examples of how this analogy is being interpreted, at least in science, is the idea of storing digital data in DNA. Some of you may not have heard of this concept, but this is not a new concept. What you can do these days, if you have a digital file, you can convert that into the binary code. Convert that into the DNA code, and then you can actually physically produce tangible material in the form of DNA. Then you can store your information. Some of the commercial examples that are being executed right now. On the bottom left-hand corner, Netflix, of all people, they've actually encoded one of their series of the Netflix series into the DNA, and they preserved that series called Biohackers in the DNA format. It was very kind of a marketing-driven campaign, obviously, and to show off their technological prowess. But nevertheless, it was a very interesting example of how this technology could be commercialized. The middle picture is a spray can of some DNA liquid. Massive Attack, the band, they digitized their album and then coded it into DNA, which was sold in this can format. The whole album is in DNA can and basically can spray around this their song in the environment. Again, there's a lot of social media type of kind of hackery and black magic there, but nevertheless, it's a real thing that you can actually do it yourself. Also, you can order DNA. You can encode your digital files into DNA, and you can order it as a physical product. Yeah, and then we can talk about the rise of synthetic biology, which literally makes bacteria as a computer. So previously we talked about interfaces, like engaging these micro versus electronics and digital interface. But these guys are literally translating bacteria equals computer, essentially, which is a mind-boggling concept to think about, especially if you think about the components of the synthetic biology. They treat genetic components in a very similar way as electronic components, like logic gates, resistors, memory, and things like that. So it's really interesting field to be in and to think about designing with living things. Yeah, so this is just a very simplified example, but you can almost envision this kind of a Arduino board as a bacterial cell, which you can control the light outputs. So one of the earliest workshops that you can do is like with the Arduino with the LED lights of switching on green and red LEDs. In a similar way, you can order genetic components to create this environment where you can produce green lights and red lights from the bacterial cells themselves. It's a very interesting, exciting area of science that designers can engage with as well. But more of that later. I just want to briefly end here, but I just want to ask some questions also and discuss anything that you want to for me to unpack further later on. But these are just the snapshots of where we are at the moment with the technology. But with the AI and machine learning, I will go into more detail in the next week's lecture. But yeah, thank you very much. And yeah, let me know.
All right. Well, thank you so much. And indeed, that the second part made a lot of sense to get a little bit deeper into some of the projects. So,
Mhm.
thanks for that. Actually,
Yeah.
we normally, I mean, so part of the assessment, I'm asking actually three students to volunteer to
Mhm.
actually ask questions. They're not always there, so hopefully this time the three students will promise to be there.
Yeah.
And this is graded as well, so
All
so
right. Okay.
they should be there. They should be there. Okay,
All
so
right.
I'm just gonna name the students. The first one was who said would be coming is a Fu Yung Han. Is a Fu Yung Han there? There's always a bit of a delay as well.
No problem.
Okay, I'm just gonna call their name. Obviously, I cannot read Chinese. I cannot even see their names.
All right.
Um,
No problem.
Fu Yung Han, are you there? Right? Just give her a chance. I'm just gonna call the second one just in case. The second one is
Yeah.
a Zhou Tungling. Zhou Tungling. Okay, that happens as well with actually no one showing up. That's great.
All right. No
Yeah,
problem.
I'm just gonna maybe my pronunciation is not very good, so I'm always gonna type their name as well to the chat.
Yeah.
There we
Yeah.
go. And Zhou Tungling, are you there? Are you ready to ask a question? Oh, all right. Okay. All right. Maybe they will get closer to the screen at some point. And the third one was
Yeah.
Tsai Yuhao. Tsai Yuhao, are you there? So any of the three students? Ouch. Or, I'm again, as Rafael just says, if anyone wants to kind of ask question, I mean, feel free to ask any question. That
Mm.
might be a little bit out of topic, and that might maybe require a little bit of digestion on the
Yeah.
side of the students, which is fine. So maybe some of the question would come back next week,
Yeah.
which is fair enough. But if one
Yeah.
of the three students are there, they want to ask question, and a last chance. So I'm just going to say your name again. Sorry for the
No problem.
mispronunciation. Fu Yonghan, are you there? Zhou Tungling or Tsai Yuhao? And again, obviously, I mean, I'm sure Raphael is happy to take questions from
Absolutely.
anyone. Yeah, of course. Right. So no one's coming today, right? Great.
So,
Okay. Yes,
if you
that's
want to
fine.
ask a question later,
Yeah,
more like an
yeah.
asynchronous thing, I'm happy to take questions via email also.
Okay,
If you don't
okay,
want to
okay.
face me in a live situation, but
Sure, sure. I'm happy for them to write down their question. I think to
mm,
verbalize them, it's part of the exercise.
all
And as I
right,
say, it's because it's an English exercise as well. Sometimes it's more about the kind of verbalization, sorry, of the question rather than actually the question itself. But we had
all
some
right,
interesting questions in the past, so I'm a bit surprised that because I did remind them this Monday, I should say, oh,
right.
don't forget to to do the question. Yeah. All right. No one has
Awesome.
got any questions of those three people. No one is there. And then among those who are there following this talk, no one's got any kind of questions. I mean, you were touching a little bit on the kind of ethical element. Is there like a debate right now in this?
Mm,
I think I understand. I think that, maybe when you are prototyping, when you're kind of developing a new technology, I think there might be, and because those microbes are also so small, it's not like
mm,
dealing with let's say with a rat or with a mouse or
yeah,
with a rabbit, which
exactly.
can very kind of usual animals. I mean, this is
Yeah,
at a much smaller scale, and I'm not sure
yeah,
whether we have developed the sensitivity I think
Yeah,
we already took some time to develop sensitivity towards a mouse. So towards, I
that's right.
think, towards a microbe, we might actually take even further time. I think maybe
Yeah,
this
yeah.
relation of time of development is interesting in regard to our relation with those microbes, in the sense that we need time as well to develop that
Mhm.
sensitivity towards them. Like you say, you were talking about announcing and or noticing. I think it takes a bit
Yes.
of time for us to notice
Yeah.
I don't know, you were talking about livingness. I think that was an interesting word.
Yeah. Yeah. Yeah.
Um,
Indeed.
do,
Yeah.
do, do you
I
want to talk
mean,
a little bit
yeah.
about that? Yeah.
Yeah. Sure. So
Mm.
for me, I mean, yeah. I mean, I started off as
How
a
do you feel about
traditional
it?
biologist, so it's
Yeah.
the idea of being sensitive to biomicrobes and noticing microbes. They're just completely alien to me. And as to
Yes.
much extent, I still agree
Yeah.
that we shouldn't really. I mean,
Mm.
I kind of like this idea of the sentience. If the things are
Sure.
regarded as
I
non-sentient
see.
and can't feel pain, I think we can be a little bit more forgiving in terms of how we
Mm.
manipulate and fabricate these things.
Mm.
Unlike, if you're working with insects or mammals, and then the
Yeah,
kind of
yeah,
conversation changes. But
definitely.
I feel like this kind of not more than human movement has kind of really aggressively latched onto this and say
Mm.
anything that's living has this kind of
I see.
moral right to be kind of treated with respect and things like that, which
Mm.
I kind of see their point of view, but practically it's not very
Mm.
sensible things to do. I mean, people have to damage or destroy or corrupt few things in order to discover things and to
Yeah, no,
find
no,
new
of course.
information,
Mm.
so there has to be some type of balance, but I feel like some of the movements are a little bit too overarching in terms of what they
Mm.
can claim and to do. I mean, like mushrooms, for example, it's a very
Yeah.
classic example. It's
Mm.
that there's a huge mushroom community that are completely in awe of this organism, and it's almost like worshipping this thing as a conscious being. It's
Yeah, yeah, yeah,
especially
yeah,
with
yeah.
mycelium,
Yes.
fungi, and things like that. So I think there has to
Okay.
be some type of balance. That's what I would
Okay.
say.
So is there opinion to say, well, we're not going to touch the mycelium, let's say in construction, in architecture, is to say mycelium belongs to nature. We cannot bring them to the kind of the realm of the artificial somehow. Is
Yeah,
there a
yeah,
speech going as far as that, or is it just
yeah.
like you say, just an admiration, a fetishism almost?
Yeah,
Uh,
yeah, yeah, indeed. Yeah, I mean, they have all sorts of terminologies to
yeah.
justify their involvement. I mean, they say collaborating with, more
Okay.
than
Yeah, yeah.
like non-human, or uh, inviting them to create these pathways for the design. It does a little bit. It does sound a bit contrived, don't you think?
Okay. Yeah. Yeah.
For me, I think it's fine
Mm.
to, yeah, fabricate these things because they're
Yeah.
non-sentient, they cannot feel pain. But I don't think you necessarily have to invent different vocabularies just to justify
Mm.
what you're doing with these microorganisms.
Yeah, but I mean, at the same time, I understand that. I think I do respect this kind of pioneering kind of element to say, well,
Mm,
you know, you are part of that kind of first wave of movement, kind of trying to say, okay, let's try to figure out those things.
mm,
But it's
mm.
interesting to see that slowly this kind of post-human vocabulary is coming into
Yeah,
into the way you talk, and
yeah,
I think you know without exaggerating. I think what's quite interesting was the kind of the Pac-Man one where, there's the movement of the light and
yeah.
okay, fair enough. It's not sentient, but it seems to be annoyed. You see what I
Yes,
mean?
indeed. Yeah,
And maybe I'm over anthropomorphizing these things, but it's a bit
mm,
like, if you point a light at someone and that person is annoyed, that is
yeah,
somehow a reaction.
yeah,
And maybe, I don't know if there's a vocabulary to kind of explain that reaction, that kind of say,
yeah,
well, that's purely biological, and as you say, there's this kind of no kind of process
yeah,
anywhere
yeah,
that goes towards, a survival instinct. I don't know
yeah,
if there's kind of any
yeah.
kind of that
Yeah, so
pushes
so
the
that project
the
was
neuronal
quite
connection too much. Go ahead,
yeah,
sorry.
exactly. Yeah, it was quite a controversial project because
Yeah,
it generated a lot of complaints.
yeah,
And then that kind of led to a conversation between academics about
yeah.
the difference between morality and ethics. So it's,
Yes.
ethically it's
Yeah.
acceptable, because it's legal and, if it's
Sure.
controlled, then it's fine. But morally, should we do it? That's another
Yeah.
thing. So
Okay.
should we create this environment that's not very friendly to these things? They are shying away from the light, So is it
Yeah. Yeah.
morally right?
Yeah. No. Okay. No. Fair enough. I mean, I think maybe this is something to kind of discuss as
Yeah.
those kind of those things are progressing. I guess I think that's the
Yes.
point. But I think it's to someone to be aware of the kind of to say, oh, these things are living, but also
Yeah.
because they're living, there's maybe a level of respect that needs to be
Hmm.
developed towards them at the same time.
Yes,
Okay,
indeed.
well, all right, but thank you so much again. And then we're looking forward to hear from my three students to see what happened. I will send them
Yes.
a mail of complaint. Hopefully they
Okay.
can prepare some questions as well.
Yes, no
And
problem.
looking forward to see you next week then. Yeah,
Yes.
if
Okay.
that's okay, to know a little bit more about the
Yeah,
AI
it's been a
and
pleasure. Exactly. Yeah. And hope you have a nice evening also.
thank you. You have a good afternoon on your side.
Yes. Thank you.
It's
We
time for
speak
lunch now,
again.
isn't it?
Yeah. Okay.
Excellent. Thank you.
All
Thank you
right.
so much.
Okay.
Okay.
Thank
Looking
you so
forward to see
much.
you. Bye
Thank
bye.
you. Bye-bye.
Bye bye. Gonna stop the record. Oops. Stop recording. All right.